Many of the problems that we're going to be seeing, we're going to be using, working with by hand, are going to be using these special angles that we've talked about. However, if you have some random angle, then cosine and sine are going to be long decimal numbers that are going to be harder to work with. That's the reason why we use special angles. Of course, 30 degrees, every 30 degrees is a special angle. That means 60 degrees as well, because 30 plus 30 is 60. And the halfway points, the 45 equals pi over 4. We've seen this picture before. This circle is the unit circle on there. And you can see that this is going to be 30 degrees. This point here, we drop it down. And now we have that x, y, and we can define sine and cosine. Sine is going to be the y coordinate, and cosine is going to be the x coordinate, since this is the unit circle. This length here, of course, is just length 1. Okay, this creates a 30, 60, 90 triangle. And we can already use the definitions we've learned for those. The blue lines, I'm just going to use this one, but you can do it for any triangle. Drop it straight down, or straight up in this case. You go straight up. Doesn't really matter. You're going to get a 90-degree angle. And this is 45, which means this angle here has to also be a 45. And here we get a 45, 45, 90 triangle. This one here, right? You drop that down. This is going to be a 60 degree. This is going to be 30. And again, we have a 30, 60, 90 triangle. Each one of these lines is going to be either a 45, 45, 90 or a 30, 60, 90 in some orientation. Here are these special ratios and everything. We have 30, 60, 90 here. It's going to be x, root 3x and 2x, and then x, x, and root 2x. Now, it's important to note that for the unit circle, the radius is 1, which means the hypotenuse is 1. So we set those to 1, and the way we can do that is by dividing each one of these things by the radius. Or by this thing. So 2x over 2x gives you a radius or a hypotenuse of 1. And then you're going to simplify it. Well, that means this has to be 1/2 because those x's cancel. This one has to be root 3 over 2. Over here, we want 1 for this. So we're going to divide each one by root 2x. The x's cancel. And we get 1 over root 2, as you can see here. And rationalizing that, we get root 2 over 2. And these are the sides we really get on the triangle. We get 1/2, 1, and root 3 over 2 for 30, 60, 90. And then root 2 over 2, root 2 over 2, and 1 for 45, 45, 90. These are important because we know that one side is x, one side y, and therefore one side is cosine and the other side is sine. Okay, so we can label each coordinate of this unit circle just using the knowledge of these side lengths of the triangles. So I'm going to start with the 45s. I think those are a little bit easier, and they're also nicer to work with. So this is a 45. The blues are all 45s. So the coordinates of this point, I'm just going to draw it here at the very end here. The coordinates of that point, well, they're both the same. It doesn't matter which one's which. So they're actually both going to be root 2 over 2, root 2 over 2. That's because we have a 45, 45, 90 triangle here. Right, this is a 45, this is a 45, and this is length 1, which means that this side has to be root 2 over 2, and this side has to be root 2 over 2 as well. That's the only way a 45, 45, 90 triangle works. That's what I just showed here. So the two side lengths have to be root 2 over 2, root 2 over 2. But those side lengths are the same thing as the x coordinate and the y coordinate. So this is what we get for the coordinates of this point. And of course, we can say, well, cosine of 45 must be x, which is root 2 over 2. Sine of 45 must be y, which is root 2 over 2. And you can go from there, do all the trigonometry. That's the benefit of understanding how do these triangles affect the unit circle, or how do they show up. So this one is once again a 45, 45, 90, right? This is 45, this is 45, or, you know, pi over 4, pi over 4, pi over 2 triangle. This has to be 1, which means these have to be root 2 over 2, root 2 over 2. However, in this quadrant, right, we have negative x. So actually, we don't have root 2 over 2, root 2 over 2 again. We have negative root 2 over 2 and root 2 over 2. The x coordinate has to be negative. That's the only way you can get into the second quadrant, is if the x coordinate is negative and the y coordinate is positive. Of course, I didn't show the x coordinate being negative here. I could have, but it's a little bit weird because these are distances and distances are never negative. But you can see it's the same numbers, root 2 over 2, root 2 over 2. But one of them is negative in this case. And likewise, I can do the same thing for the other two coordinates. This one here has to be at negative root 2 over 2, negative root 2 over 2. And this one here, the only way this one will work is a positive root 2 over 2 and a negative root 2 over 2. Okay, so those are the 45, 45s. Now I will show these ones here on the axes. These are the easiest ones to know. This one, of course, is at 1, 0. Again, this is the unit circle, so it's a length of 1 out. Well, it's only 1 out here. So it has to be 1 for an x coordinate and 0 for the y. This one up here is going to be at 0, 1. This one over here is going to be at, I'm going to do negative 1, 0. And this one down here is at 0, negative 1. Those are the 90, 180, 270, and then, 0 or 360. The same thing as pi over 2, pi, 3 pi over 2, and 2 pi. Okay, now we're going to look at the 30s and 60s, and these are all based on this triangle here. The important thing to note is that root 3 over 2 is the longer side than 1/2. Okay? So whenever you're looking at these triangles, the longer side's always going to be root 3 over 2, and the shorter side's 1/2. So this side, this one right here, we know this is a 30, 60, 90 because this is a 30 degrees, which means this has to be 60. And which one's longer? This bottom one's longer. That means this has to be root 3 over 2, and this one has to be 1/2. Of course, this length here is always equal to 1. That means this coordinate, the coordinates of this point here on the unit circle, is going to be at root 3 over 2, 1/2. And this next triangle here, this is again a 30, 60, 90. If I drop this straight down, this is going to be 60 degrees now. This one's 30. This short side is 1/2. This longer side here is root 3 over 2. Of course, this is always 1. That doesn't really matter. So now we have 1/2 as the x coordinate, and root 3 over 2 is the y coordinate. Okay, moving along, doing the same process here. For this one, you can see that the y coordinate is longer than the x one. So this one has to be, let's see, the y coordinate was longer, so x is going to be 1/2. The y coordinate is longer. And the only way you can be in this quadrant is if x is negative. So we have negative 1/2 root 3 over 2, which makes this one root 3 over 2, negative root 3 over 2, 1/2. There's the flipped version of that. Again, you can make a 30, 60, 90 triangle out of there. 30, this is 60. So that makes this one 1/2, this one root 3 over 2. And you can get the coordinates from that. And then continuing. So let's go down here. This one, both x and y have to be negative. Here we have a shorter y coordinate, so we know y is going to be 1/2. X is going to be root 3 over 2. They're both going to be negative. This one here is going to be negative 1/2, negative root 3 over 2. This one here is going to be, let's see, drop it down. We see the y coordinate's longer, so we're going to have a 1/2 root 3 over 2. And x has to be positive, y has to be negative in this quadrant. That makes this going to be root 3 over 2 negative 1/2. And so that's the naming conventions for each one of these things. Just think about these triangles, and you can name each one of these quadrants, or each one of these special points. And we're going to be using these points a lot. And the important thing to note is that if you can understand what's the coordinates of these points, then you know what sine and cosine are of these angles. Right? So if I looked at it down here, sine of negative 135, let's see, that's going to be, negative is going to be clockwise direction. This is 90 degrees, and 135 is going to be right here. So the sine of this angle, right? This point goes to this here, to that quadrant. Sine is the y coordinate, which means it has to be negative root 2 over 2. Secant of 11 pi over 6, this is the same thing as 1 over cosine of 11 pi over 6. So 11 pi over 6, 11 pi over 6 is going to be 1 pi over 6, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, 8 pi, 9 pi, 10 pi, 11 pi over 6 is right there. The coordinate is going to be this coordinate here, and that's going to be cosine of this angle. That means cosine has to be the x coordinate, root 3 over 2. But of course, that's going to be 2 over root 3, which gives you 2 root 3 over 3 when you rationalize it. Okay, cotangent of pi, well, it's the same thing as 1 over tangent of pi. Pi is quite easy. Pi is just 180 degrees. This is cosine. Cosine of pi is negative 1. Sine of pi is 0. And tangent is y over x. Y is 0. Negative 1, so this is yx. So tangent is y over x. Y is 0, x is negative 1. Multiply by the reciprocal, we get 1 over negative 1 times 0. But that has 0 in the denominator, which means this is undefined. You can't find that answer because you have 0 in the denominator. That's kind of a basic way of doing this. You're really just looking for what's the x coordinate, the y coordinate, depending on if it's sine or cosine. And then if it's tangent or cotangent, remember tangent is y over x, and then go from there. Give it a try in number 2.